Alright, I am here today. I am going to be giving this project update. I call it a project update, but this is the first one, so project status something or other. Anyways, so this is working title Sword and Coin, Wand and Grail. It is eventually going to be a turn-based tactical RPG, and the aim is to capture a certain type of feel of playing a tabletop role-playing game. That being the sense of open world, basically. Mount and blade is the feel that is being aimed for with this project. But the other side of that also being like a lot of even games which adapt directly tabletop RPGs lose the tactical turn-based element when adapted to video games. So that is also something that I am aiming to implement. Now, with that being said, none of that is really relevant to this particular update because the project is not close to that point yet. Instead, what the other aspect of this is procedural world building. So we have here in front of us this very nice globe. It is not remotely a nice globe, it is a terrible globe. So these, you can kind of see this ugly checkerboard pattern, and you can see these seams here. Essentially, this is a globe the size of a globe. So the world is divided into this distance here. You can see there's like a slight gradient here. That's each tile being assigned its own color, and then when it gets to the end, it kind of has a fade along two different axes, two different colors. It's kind of hard to see, but if you see that little white pip at the point of my mouse cursor, that is a single tile. It is a distance of 400 tiles along this seam, and each tile is a hexagon 12 miles across from middle of the side to middle of side. So it's 14 from opposite corner to opposite 14 miles opposite corner to opposite corner. Internally, this is divided into regions. You can see this being a region here. It basically, coordinates are x coordinate along from the top of each region, increasing as you go along this axis. Y coordinate, increase 0 at the top of each region, increasing as you go along this axis. And the region itself, there's also a coordinate for that comes first. There are 10 regions. The world is essentially treated as an icosahedron, not in distances. Distances are mapped on the globe itself, but kind of conceptually divided into an icosahedron with a top and middle or bottom and middle region being formed together to be a single rhombus. So there are 10 of those regions. Right now we are looking mainly at region number 5. Region number 0 is the one that would be on the prime meridian. It is a southern region, so it would be one of these southern polar triangles, and then the right side up equatorial triangles. But we are right now looking at the back of the globe. This would be the international date line. So yeah, this is region 5. Region 4, you can see region 3 up here, region 6 and region 7 over here. So, moving from that, we have junk data. This is an old viewing mode. It's not actually, you can kind of see, because the data being input into here is mostly derived from the, I mean, it's all being derived from the data that is being sent to the graphics shader. So this is, you can kind of see the outline of the noise as it exists, but this isn't a proper viewing mode. This one is, and we are going to have to kind of rotate it a bit. So the first thing you may notice is there are these very obvious circles here. This is a, I would call it an artifact, but it's not even an artifact. It's like just straight up a how things are being calculated. Ocean regions over here, continental regions over here. This is a base elevation of negative 14,500 feet in the ocean regions and of negative 500 feet in the continental regions. The continents are right now calculated as a very simple, you pick 7 points on the globe, and then it's essentially the largest circle that can fit within a Voronoi region. So you can see here that these two continents touch. That is because this continent down here is the closest to this continent up here. This continent up here is the closest to this one down here. This one over here, there's a bit of a gap. What it's kind of looking like is this continent is smaller, so it doesn't reach all the way. The artifact here being that you get these very ugly seams where everything immediately drops off to 0. Or not 0, to super below 0. That is something that I will eventually swap out these, what I'm thinking for the continents replacing this. So right now you can see all of this terrain noise, and you'll also notice that despite calling them continents, they're not remotely a single landmass. This is because this is just a very simple negative 500 feet with noise added. So there's nothing to kind of get it into a single landmass. Eventually, and there was a previous version of my project which did have this, so there would be a rise implemented so that the baseland in the center is higher than on the outside. Right now I'm mostly aiming to get the various data structures working on this. So implementing that kind of rise is not an immediate concern. And also, I don't like these circles to begin with, so I'm probably going to wipe them out and replace them with another system later. The system I am thinking of is, so right now there are 4 octaves of simplex noise which are used to generate this noise. The largest octave of noise has a gradient at each vertex of the icosahedron that the world is derived from. And then it is 4 octaves of noise, so that is the highest one. There is another one which is 4 times the resolution, I think, or 1/4 the resolution. Yeah, 1/4 of the distance. So rather than being a point every 400 tiles, it would be a point every 100 tiles. I actually want to change that because I think there's not really much of a point of having a second large scale thing. So I think I want to change that to 1/5 every 80 tiles. Then there's a third octave at every 20 tiles. And a 4th octave at every 5 tiles. So what I'm thinking is do a set of Voronoi regions for the world, with each point will be based on the center of that evenly spaced, rather than taking the faces of the, essentially these triangle faces are, you take one of the icosahedron triangles and you subdivide that 400 along each side. Rather than doing that, do it 20 along each side, but then implement some irregularities in the form of scattering each of the centers to get a Voronoi region. And then what I'm thinking is, because right now there's not anything, there's no noise adjustment like I mentioned. So, but like, let's find a good one for this. Thought I had one. Or I didn't. Okay, over here. Like this here, this continent here, which is the smallest probably. One of the artifacts of the way I'm currently doing continents is, by definition, the two smallest continents will always be right next to each other and the exact same size. But look at how neither of these continents really has much land. So once that raising the land to generate an instant coastline thing would be added, then at that point, like, what's the point of the largest scale noise if it's just going to be compensated out by other parts of the function? Now, to a certain extent, it would still be present in stuff like this, where this stuff is very raised and this stuff isn't, and there's that ugly seam there. I have to fix some things with the noise generation. But, so what I'm thinking is, rather than having all four of those octaves of noise applied directly to the land elevation, have those first two be used to generate which of those resolution 20 tiles are considered part of a continent or not part of a continent. And then from there you use the lower two octaves, and that's applied as the actual land elevation. However, right now I'm just working out the data structures, so that's not an immediate concern. Regarding this noise, I'll just mention this now before it goes off of the console. I have a console window open, a bunch of debugging information. I don't really have any sort of user interface on this right now. But so this noise was generated in 270 seconds. Now, the other thing to note is that as I was recording this, I noticed that it was running at 40 FPS while it was generating instead of 60. So I believe part of that was OBS while recording also kind of slowing it down, maybe. So it was 270 seconds to generate this. Usually it's a bit faster than that, so just kind of adjusting that. We're looking at right now 3 minutes to generate this noise, which is, it could be better, but it's not terrible. The other thing to note is that we're generating this noise in the ocean regions. We don't actually have to do that. The program does not actually internally track all of this elevation data because this is out in the ocean where nothing happens. It only tracks tiles that are within a continental region. I generate that at runtime for the purpose of being able to display it and debug the noise and whatnot. But So that is actually a significant portion of the world generation that is currently only in there for debugging purposes. So, on to the next viewing mode. This is precipitation data, and I am sorry for the kind of not really great contrast. And it's not really gonna be very explainable in this mode because you can't see the continent edges. So basically what happens is the globe is divided into 6 equal latitude regions. And those are given prevailing winds based off of very basic level climatology, super simplified, but simplified is enough for here. And that is given as a prevailing wind vector. Each tile has its wind modified by a vector going either towards or away from the center of its continental region based on the current season. I mean, right now we're not tracking time, so like there aren't seasons going on. But it basically does 7 to determine the annual precipitation. It does 7 precipitation readings throughout the year. Essentially, the summer equinox or summer solstice, winter solstice, and then 5 regions between, which are then doubled to account for each month going in and out. So then that is used to determine the annual precipitation. The way that is done is we take the vector and it is given a value based off of the derivative of the noise value, the noise gradients from the simplex noise, in the direction of that gradient. So if the terrain is rising in that direction, more precipitation. If the terrain is falling in that direction, less precipitation. Additionally, there is a boost applied to the larger scale noise gradients in that calculation. This is done to, it gives them an outsized effect relative to how much they actually contribute to the actual elevation, but this is meant for the purposes of simulating essentially being in a rain shadow. So that even if you're technically not if your high slope, if your large scale slope is relatively steep but being counteracted by shorter scale slopes, smaller scale slopes, then the program will still give you less or more, a more exaggerated effect, basically to represent you being going up the slopes of a mountain or in the rain shadow of a mountain. I don't really have a good enough view to tell if this is actually giving the effect I want, but it results in... That was less dramatic. Sorry, I was meaning to do this. Terrain data. So what we have here, this is the end result of what the precipitation data is used for. This is combined with temperature data, which right now is derived basically just from distance off of the equator and elevation. So you have this salmonish orange, not peach, is desert. You've got this kind of very thin yellowy, yellow-green, that is grasslands. Then you have sparse, medium, and dense forests. And then up here you have tundra. It appears a lot in the middle of dense forests up north. Now this here is due to elevation, when it gets higher, it goes to tundra. I'm thinking that I need to adjust how dense forests are in low temperature regions, because you can see, like, up here is the North Pole. We're pretty far north. So that's all stuff that needs to be calibrated. And on top of that, we have this viewing mode, which immediately goes to nothing. Let me just zoom out a bit. Map viewing mode. This is the mode that the player would actually be viewing through. So it's viewing the same thing, but I mean, not the same thing, it's actually a different geometry, but same map data, so these should correspond. And so, let's see. So you have this, the white hexagon that is under the cursor that is the currently highlighted tile. If we click, that selects a tile and it outputs some information about the tile to the console where you can't see it, but I can. If we click on this tile here, this white octahedron, which looks just like a square to you because there is no sort of lighting or shading or anything on it, these represent party data. Right now that's currently in the debugging phase. That is why it's just out in the middle of the ocean. But if you click on that, the party is selected. If you click again, it is deselected. If there were multiple parties, it would cycle through the parties before then reverting back to not selecting anything. And if I go here and right click, it moves the party to the new location. And it also outputs currently calculates the distance between the two and also gives a list of the tiles from those locations in a straight line. There's no proper pathfinding right now. Also, despite giving a list of the tiles between the 2 points, this does not actually pass through those tiles. It immediately teleports to its destination because I am a bit behind on my objectives. Having actual timekeeping and pathfinding and movement over time was something that was supposed to be done by the 1st of July, but was not. And let me see what else. I think that is currently it for existing features. There are not very many. So, upcoming features. The current goal for the next 3 months and also for the rest of the year. By the end of... So, the goal for the next 3 months, to be done by October 1st, 2022, is to have... Well, first off, to finish those things that I was supposed to do by today, but also to do the next layer of gameplay, which is the dungeon interaction. So to have the general data structures for the dungeons and be able to move characters around, hopefully also to interact with things within the dungeon. Don't know how far I'm going to get with this. Right now I currently have nothing in regards to having the dungeons implemented, so this might be rather tight in terms of time to get this implemented. The end of year goal is to also have the layer after that, the combat, implemented. This seems like it should be at least a bit easier because it's occurring at the same scale as the dungeon, but with, rather than the kind of pseudo RTS command scheme that the dungeon exploration will use, this will just be turn-based tactical. And the combat will not be fully implemented. We're just looking at the basic level of, checking line of sight, moving, initiative order, taking a turn, doing damage, or making an attack and doing damage, having hit points, having a defense, having items equipped. Not everything will be implemented, but hopefully the framework will be done by the end of the year. Actually, and then there's just, you can see some other tiles here, parties here. There are 3 for each continent, just kind of scattered throughout the world. And so beyond all of that, other things that I would like to do, these aren't explicitly baked into the current goals, but I would also like to address them by the end of the year. First off, where is a good example? I had one earlier. This. Something is going wrong at the seams on the noise generation, because if you zoom in, like, you can see this straight line here. Right now, this is considering these 2 separate tiles, but they should both be evaluating the noise at the same point. For some reason, they are not. I don't know what's causing that. I have identified a different bug within the noise generation, but it shouldn't be doing anything along the seams. It should be doing things in the middle, like maybe this is this straight line here might be caused by that. So I don't know what's causing these edges along the seams, but I'm probably going to rip out completely or make some changes to the way the noise is done, which will involve basically ripping out the entire code and structuring it in the noise generation code and structuring it in a new way. So hopefully that will fix this in the meantime. And then, see, right now it would actually be easy for me to get it to treat these as one tile, but I don't actually want to do that right now, because right now treating these as 2 tiles cleanly shows to me whether or not I have fixed this bug or not. So I kind of don't want to fix that at this moment. But additionally, previous versions of the program that I scrapped in order to redo how things work at a kind of lower level with how the world data is structured. And also earlier versions were prototyped in the Python version of Panda. This one is C++, and it works much better for what I need it to do. So, but I would like to also, by the end of the year, implement the features that I had in those versions, which are not currently in this one. Mainly that previous versions also had runoff calculated so that there were rivers on the terrain, and also there was society level data. So you had various kingdoms, you had cities placed. So those are the things that I am working on for. Those are things I would like to do in the next 6 months. However, those are secondary to the main concerns of getting the dungeons and the combat working, which going into the next year, that will give me a nice framework where I can work off of everything and to have a lot more options in regards to, next steps on this program. I think that part will be the very basic level of the program written out. And from there, I can work into turning it into something that can actually be a game. And I think that's about it for today. So